Hello again. We'll continue our discussion of scientific problems for the naturalistic origin and evolution of life. I do want to say here at the beginning that in addition to being a school teacher, I'm also director of the Southwest Dallas Reasonable Faith chapter, and I don't want to imply that what I'm presenting today is either endorsed or not endorsed by the Reasonable Faith organization. Some of what I'm going to present today could be considered a challenge to the standard view about the origin, the naturalistic origin and evolution of life. I hope to back it up with documentation so that you can research this and determine if it's true or not. It is true, but everyone needs to be able to have the opportunity to look up the references themselves. So I'm going to try to add a lot of references at the end of this presentation to the video that you're watching, but there's no way to add all the references, so I'm going to refer you to a book here. This book, Origins of Life, is an excellent book. It has a lot of detailed references for each chapter. This book is Origins of Life, written by Dr. Fazal Rana and Dr. Hugh Ross. It was copyright 2014, very recent. And especially pages 81 through 87 is what I'm going to be talking about today, rather than the entire book. The entire book is excellent, and recommend that you and your students read it and look up references for the whole book. But today on this video, emphasizing pages 81 through 87. And now we'll continue with scientific problems for the naturalistic origin and evolution of life. We're going to review part one. Part one was shown at a Southwest Dallas Reasonable Faith chapter meeting in the last couple of months. But if you're watching this video, probably you've never seen that, so we're going to do a quick review of part one. Refer to this book that we just told you about. And everyone is familiar with the standard naturalistic view of how life started. Charles Darwin, for example, suggested that perhaps life started in a warm little pond, undirected, no intelligence behind it, that somehow over a long period of time life may have started perhaps in a warm little pond. Others have suggested perhaps in cold conditions or hot conditions, in hot water vents and that sort of thing. But this is a quote here from Dr. Carl Sagan from 1966, and he says, "The apparatus for the transcription of the genetic code must itself have evolved slowly through billions of years of evolution." And what I'm going to present to you today calls this statement into question. A huge amount of scientific evidence has been found since 1966 that does call that statement into question, that life and the evolution of life occurred over a period of billions of years. Prior to about 3.85 billion years ago, early Earth had not yet cooled sufficiently to form a solid crust and oceans as permanent features. This is a summary from a part of a book called Rare Earth from the year 2000. It was written by Peter D. Ward, Dr. Peter D. Ward, and Dr. Donald Brownlee. Dr. Hugh Ross says that therefore it is very unlikely that life could have originated on the Earth before 3.9 billion years ago. Now we're going to talk about something that very few people have heard of. Very little is discussed about this in the schools or elsewhere for that matter. And yet it should be. It's very important for discussions of the origin of life and also of the evolution of life. So what is the late heavy bombardment? What are we talking about? The late heavy bombardment was something that was discovered by scientists after the Apollo astronauts went to the moon and brought back many rock samples from the moon. There was also other sources of moon rock material, such as the Russian Luna satellites that were sent to the moon. They were unmanned, but they brought back small amounts of lunar dust and lunar rock from the moon to the Earth, and that was also examined. And then in addition to the many, many pounds of rock brought back by the Apollo astronauts, naturally blasted meteorites that were blasted rock from the moon to the Earth. Meteorites hit the surface of the moon, and in a few cases, some of those rocks shot up into space, and some of them were drawn by gravity to the Earth. And scientists have found a few of those rocks that originated on the moon that came here naturally through asteroids and meteorites hitting the moon. By studying all three of those sources, Apollo rocks from the moon, Luna dust samples and rock samples from the moon, and meteorites that came naturally from the moon to the Earth, scientists have discovered something I think is very amazing, and that is something called the Late Heavy Bombardment. If you look at a picture of the moon, yeah, you can look at the moon with your unaided eye, but if you look at and you can see what people call the man on the moon when you look with your unaided eye. The man on the moon is actually scars or craters from enormous asteroids that hit the moon in the past. If you look at a picture of the moon, in this case this is from NASA, and some of these enormous craters or basins, if they're really enormous, they're called basins, are dated, and scientists have dated these by looking at the rock samples that I discussed from the moon. An example is the Imbrium Basin here, and it's dated at about 3.85 billion years ago. Another example is Oriental, which is dated from about 3.8 billion years ago. And that date, 3.8 billion years ago, if you'll keep it in your mind, remember it, it's going to come up more than one time in our discussion today. But by discovering that very many of these very large craters and basins were formed in a short period of time, scientists have discovered that the moon, and then of course also the Earth, which is very near the moon, were blasted and bombarded by huge numbers of asteroids, and very, very large asteroids, and very many of them, for some reason, hit the moon and the Earth. And the time period for the Late Heavy Bombardment has been narrowed down to either 4 or 4.1 billion years ago to about 3.8 billion years ago. This is important for several reasons, but particularly, and here we have the most intense time of the Late Heavy Bombardment, 4 or 4.1 to 3.8 billion years ago. We discussed this in part 1 of what we're talking about today, but I'll try to repeat a little bit of this quickly. This is an artist rendering of what an enormous asteroid would have looked like as it crashed into the Earth during the time of the Late Heavy Bombardment. Larger objects and many, many more objects, maybe 25 times as many objects would have slammed into the Earth as slammed into the moon. They would have been larger, and there would have been more of them. By looking at the pockmarked surface of the moon, if you realize that 25 times as many hit the Earth, it was amazing. You wonder why don't we see all these craters on the Earth? And the reason for that is that the Earth weathers. We have weathering on the surface of the Earth that does not occur on the moon, and that weathers away signs of these ancient craters. And then in addition, there are plate tectonics where magma underneath the crust of the Earth circulates, and it actually pulls over a period of many, many millions of years. It pulls the crust down under the surface and melts it and recirculates it and recycles the crust of the Earth. so that we do not see most of the craters that were here on the Earth, 3 and 4 and more than 4 billion years ago. However, scientists know that they were there because of what they can see on the moon, because the moon craters have not been weathered away, and because they've examined the actual rocks from the moon. This is a clip from a video that we saw in the last month or two in part 1, and some of the enormous asteroids that hit the Earth in the late heavy bombardment were so large, 500 kilometers and more, 500 kilometer diameter objects. If they hit the Earth, and they did, they would vaporize within seconds. You imagine something 300 miles across, 500 kilometers across, vaporizing in seconds. And that's such a huge amount of vaporized rock that vaporized, superheated vaporized rock would have circulated across the entire planet. It would have vaporized all of the world's oceans. It would have vaporized the salt that used to be part of the world's oceans. It would have vaporized the top layer of the rock around the entire surface of the Earth. It would have vaporized it, and then below that there would have been a layer of molten rock around the entire surface of the Earth due to a 500 kilometer object slamming into the Earth. And so at one of our previous sessions, we showed a video to give a visualization of what that would be like. So what I'm going to do here is I am going to stop our video now, and I am going to play a artist rendering of what it would look like if a 500 kilometer object slammed into the Earth today. And this video comes from Miracle Planet is the name of the video series, and it's copyright 2005, and it comes from the National Film Board of Canada, copyright National Film Board of Canada. And just so you know, this video series happens to be pro-evolution, but very few people seem to be aware of the late heavy bombardment, and so I want to give you a visual idea of what it would have been like when any of these several 500 kilometer objects hit the Earth back at the time of the late heavy bombardment.